Hello, my name is Scatterplots. I'm a lecturer for research methods at the University of Glasgow Acoustic Centre. And today I'm going to talk to you about interpreting scatterplots. Behind me you see a scatterplot, a very simple one, but I think it will show you very clearly what they're about. But first, why would we do scatterplots? Scatterplots are a great way to show in one quick snap the relationship of two variables. The variables need to be continuous or have a lot of categories for those to make sense. So here, for example, I might be interested in the mean age at which someone receives sex education in various countries and the related mean number of sexual partners. The scatter plot here presents that relationship. You see the labels for the countries showing the mean ages as well, the mean ages for sex education, as well as the mean number of sexual partners. So what do we do when interpreting scatter plots? We have to first, and you should always do this, and you train yourself, start looking at what do we see? Not to interpret what's presented, but what is actually displayed. And the first thing to look at are the axes. Here, the x-axis is the age of sex education, and the y-axis, the mean number of sexual partners. The second thing to look at in terms of what's displayed is the title. It just says sex education and sexual partners. We get some more information of this when we then look to the main area, the graph area here, and see that actually the data points, the black points that you see here, are labeled with country names. And so we know that these are the mean ages in a country and the mean number of sexual partners in a specific country. Once you know what's displayed, you might want to start interpreting what's displayed. And scatter plots are particularly good in looking at overall relationships. Unique observations, like for example, Turkey, that sticks out here. And clusterings, groupings of observations. So you have a group, Romania, Italy, Spain, that sits here, maybe a little bit off the overall trend. So unusual cases, overall patterns, and groupings are the particular strength of scatter plots. And that's what you interpret in the second step. Once you've done the interpretation, once you know what's displayed and what the results are, unique cases, patterns, and the overall relationships, you should always also consider the trustworthiness and truthfulness of what's interpreted. The trustworthiness and the truthfulness of how it is displayed. The first thing to look at in all graphs are the axes and how they actually display the quantitative data. Let's focus just on the mean ages here. Is this a good way of displaying the mean ages? In this case, it is. It covers all data points that we have, and it's not a variable that has to start at 0. If we were to look at age in general, we should include 0 to have a truthful display of the potential distribution of that specific variable. Similarly, we have mean numbers of sexual partners rather than sexual partners for an individual, where it's very conceivable to have zeros. So this seems to be a good presentation. The second thing to look at is the title, which usually very clearly indicates what's the purpose of this overall graph. Here it only says sex education and sexual partners. Well, this is a bit misleading. And I think this gives you a first indication of how careful you need to be with this, because it's not sex education and sexual partners of individuals, for example, in the UK or in the US, but it's across a whole range of countries. These are mean numbers of sexual partners and mean ages of sex education. Therefore, the title could be clearer, and well, we might want to say we're not quite sure how well this is presented. The last thing, and this is really important, is to say what is actually the underlying data. And if you ever present your own graphs, you should always have that information very close by. Ideally, like in this graph, as a caption just below, a footnote. Here it says the source of the data, and this source of this data is the 2010 Durex survey. And that survey is actually publicly accessible. It's open data. You can have a look at the report and look at the data that I've used to create this. If a source is not displayed, you should always be very wary. And this is actually some tip particularly important for the age of social media and sharing, where it's quite easy to make a screenshot of this or just take a graph out of a report in its context. Therefore, I would strongly suggest that when you do a histogram, a scatter plot, box plot, or any type of graph, that you always have a footnote included in it that gives the data source. And that if you share something, that you never ever cut that information off, because otherwise it's just some nice graphical display that you can pull off your head. So to just summarize, interpreting a scatter plot should always start by saying, what is displayed? Look at the axis, look at the title, what is displayed? Then you look at relationships, that is patterns, clustering of observations and unusual cases. And then a third step, and this should always be a third step, don't just stop there. You should always check for the trustworthiness and truthfulness of the graphical display. Is it actually displaying what it's meant to say? Title. Is the source clear? Are the axes not kind of fudging things, but actually displaying a sensible range of values? If you want to create your own scatter plots or look at what I've done using the data, you can follow the link underneath this video. It shows you the R code for doing this scatter plot and gives you the data as well. If you're interested in learning more about quantitative methods, have a look at the other resources that we have put together from the University of Glasgow's Q-STEP Center. And also, this is a display of what we do in our quantitative methods degrees. Thank you very much for your attention, and I hope you like it.